OK, let's talk about TCP attacks. So as we've talked about TCP and how it's implemented, one thing you'll notice is that at no point did we mention anything about cryptography. We didn't say encryption. We didn't say anything about MACs, signatures. So TCP by itself doesn't have any cryptography built in. And that means that it's vulnerable to some of the network attackers that we talked about. And in particular, we will look at attacks that try and change or add malicious data into the TCP connection. So remember that once a TCP connection is formed, it creates a byte stream where the sender can feed data into the pipe, and it appears on the other side in the same order reliably. And a TCP attacker might try to add malicious data into the pipe, and the recipient doesn't know any better when they receive that malicious data. Or maybe the TCP attacker tries to modify data as it's being sent across this imaginary TCP pipe. So in particular, we will look at two different types of attacks. Sometimes they're both called types of TCP hijacking. But one type of attack has to do with injecting actual data that the recipient's application is going to process. And the other type of attack is terminating a connection early by injecting a reset packet. And remember, a reset packet stops a connection right away, usually used for errors, but an attacker could use it to be malicious and stop a connection from happening. So these are the two types of attacks we'll look at. And now we'll think about what each type of network attacker needs to execute these two types of attacks. So first, we can start with the most powerful attacker. That is the man-in-the-middle network attacker. They can read data. They can also modify data as it's sent across the network. And because TCP has no cryptography whatsoever, then this is a piece of cake for the man-in-the-middle. They see the data being sent over the TCP connection. They change it. They drop it. They add their own data. It's easy. All they have to do is change the data, and the attack succeeds. So if you're a man in the middle, both of these attacks are easy for you. You can change whatever's being sent across the network. Now, what if you're an on-path attacker? Well, now you can't change the packets as they're being sent across the network, but you can spoof your own packets and pretend like they came from the sender. So this is what that might look like. Here's a diagram that shows TCP data injection. So let's say the handshake has already happened. The client and the server have already agreed on their initial sequence numbers, and they're starting to exchange data back and forth like they usually do. But now, instead of the server sending some data to the client, which is what's supposed to happen, let's say an on-path attacker creates their own malicious packet and pretends to be the server and sends it to the client. So if you look at this packet in red, well, who's it actually coming from? The attacker. Who is it being sent to? The client. But when the attacker sends it, they're not going to say, this is from the attacker, and this is going to the client in the header, because then the client would know this is not coming from the server. So instead, even though this packet is coming from the attacker, remember that the attacker has to lie. And when they create this header, they're going to fill in the header field and say, this is actually from the server. Now, is it actually from the server? No, that's a lie. But by spoofing a packet, we can inject this data into the connection. And the client will receive this data and possibly process this data as if nothing malicious happened. So we can think about what needs to happen for this malicious injection to succeed. Well, one thing that needs to happen is that the on-path attacker has to be able to fill in all of the fields of the packet. So usually, we'll assume they know the IP addresses of the server and the client. They could also see those IP addresses by reading one of these earlier packets. What else do they have to know? They have to know the sequence number. So how does the attacker know the sequence number? How do they know what y is, or y plus 1, so that they can fill in y plus 1 right here, so the client accepts this value? Well, the attacker can just read this packet sent in blue. They can read this value of y plus 1 and then write it down in their malicious packet. So that way, this packet looks like it's coming from the server and has the correct sequence number. Now, one final note is that this packet needs to get there before the legitimate response, because it could be the case that the server also has a packet with legitimate data starting at number y plus 1. So it should be the case that this attacker wins the race condition, their packet gets there first, the server's packet gets there late, and in a case like this, the client will usually just drop this packet because it's a duplicate and they've already received something with sequence number y plus 1. So this is what TCP data injection looks like if you're an on-path attacker. You know how to fill in all the fields because you can see all these packets. You're going to spoof a packet, and you have to get your packet there first before the server's legitimate packet. Those are the conditions for an on-path attacker. So it's a little bit harder than the man-in-the-middle attacker who could just change this data. But it's not that hard. The on-path attacker can still do this and succeed most of the time. So that's what an on-path attacker's data injection would look like. Now finally, let's go to the off-path attacker. The off-path attacker is someone who cannot read or modify packets. So the attack looks somewhat similar. The off-path attacker wants to create a spoofed packet, pretend like it's from the server, send it to the client, and hope that the evil data is accepted. And as before, there's still a race condition. The off-path attacker has to get there first. But now there's an extra challenge. Remember how we said the on-path attacker knows y plus 1 by reading this packet? That's something an on-path attacker can do. It's not something an off-path attacker can do. If you're an off-path attacker, you can't read this packet. So you don't know what number to put here. So you have to guess this number. So the off-path attacker has one extra thing they have to do that makes their version of the attack even harder than the on-path attacker's version. And that is the fact that the off-path attacker has to guess this number right here. They don't know what number it's supposed to be, and they have to guess it. So to put it all in text, the data injection attack is easy if you're a man in the middle. It's easy if you're an on-path attacker, although you have to win the race. But everything else isn't so bad. You spoof a packet. But if you're an off-path attacker, you have one extra challenge, and that is that you have to guess that sequence number. Because you don't know it, you haven't read any of the previous packets. Sometimes the off-path version of this attack is called blind injection, because you can't see what packets are being sent. And depending on your threat model, this might be considered difficult. It might be considered easy. It's up to your threat model. But usually 2 to the 32 is roughly 4 billion, so we assume this is pretty hard to guess right. And it's also pretty hard to send 4 billion packets to try and get one with the right number. So that's what data injection looks like. Now, reset injection is basically the same thing. The only difference is that instead of sending actual data that you want the recipient to see, like send Mallory $10, you will instead inject a packet with the reset flag turned on, and whoever receives that packet is going to drop the connection and leave it forever because they will think that the connection has been terminated. So the requirements are basically the same. The only difference is what data you're injecting. Instead of injecting actual data, you inject a reset packet. Once again, if you're a man in the middle, it's easy. Just take your packet, set the reset flag on, and send it to the recipient. If you're an on-path attacker, it's still pretty easy. You can spoof a packet, and you know the sequence numbers to fill in. You just have to make sure your packet gets there first. And once again, if you're an off-path attacker, you have to guess that sequence number, which can be difficult. So basically all the same requirements for reset injection. And if you're curious why you might want to do this, you could maybe use reset injection to censor a connection you don't like. So if you see two people talking and you don't want them to talk, you could send a reset packet or inject a reset packet and then try and stop them from talking to each other. So this is data injection. Reset injection is basically the same thing. You just swap this evil data with a reset flag.